Bismillah ar-Rahman ar-Rahim, June 2024, 42 variant and complete mechanics paper. We are going to start. So question number one, and best way in the whole paper, and let me clear, okay, best way, write data and make diagram. Cyclist and bicycle has a total mass is given 72 kilogram. Units you ride, you don't ride, no problem. Cyclists ride along horizontal road against a total friction, and friction is 28 newtons. If you ride even, no issue. If you don't ride, no problem. Total work done by the cyclist to increase speed from 8 to 16. It means starting speed U is 8 and last velocity again 16. And distance is 100 meters. And we have to find out the total work done by the cyclist. So we will apply a magic formula here, and what is the magic formula says? We have to find out kinetic, because magic formula is basically work done by applied force, work done by frictional force, kinetic energy plus potential energy at end point. Okay, let's say it's starting from A and ending at B, just sake of understanding. So end point is B, and minus kinetic energy plus potential energy starting at A. Basically, it's traveling is a horizontal track. So what is the height at A, height at B? Both are zeros, so they are cancelled. So I have to work for this now. So work done by frictional force, basically friction force into distance. And that is very clear. Friction force is 28, distance is 100. So I got 28 times 200. So 2800 joules. Now I talk about kinetic energy at a B. Kinetic is to half mv squared. So VB is a 16. So this is a one thing. And kinetic energy at A, half m A. And at A, which speed is 8. So 8 to power 2. So that's it. And just I'm going to find it half into 72 into 16 square. I got it first one. 1 minute, please. Let me check again. So half into 72 into 16. So I got it 9216 joules. So I think this part is okay. And now same way, if I check it down, I got 8 square. I got 2304 joules. And now students, I have to plug in the formula. So put in 1. So work done by applied force is the target. Friction force 2800. And kinetic energy at B, I just got it this. So 9216 and 2304. And this will go and add, and I will get my answer. So 9216 minus 2304 and plus 2800. And my answer turns to be, if I'm writing like this, final is 9712 joules. So work done by applied force. So I hope so. The concept is very clear and the question is over. So students, question number 2, a particle P moves straight line, okay? And after leaving O, its velocity is this formula, right? Set of values of T for the acceleration is positive. Students, make sure the main thing is what is here, displacement. Whenever we have a displacement, if you differentiate of displacement expression, this rule is implements only when we have given this kind of expressions. So I will get velocity. And if this is difference with respect to time. If I differentiate again with respect to time, I will get acceleration. Okay. And if I want to come down below level, so I have to integrate with respect to time. Again, velocity to displacement, integrate with respect to time. I think point is clear. Currently, I am on the velocity level. He asking that the value for acceleration is positive. Acceleration means I have to move one level up. It means I have to differentiate. So V is equals to 44t minus 60 square minus 36. If I differentiate dV by dt, so 44t become 44, 2 comes down and power 1 less is 0. And I got acceleration according to situation. What thing he said? He said that you have to make it positive. Positive mean A must be positive. If A is positive, it means 44 minus 12t must be more than 0. So what to do onwards? So have a look here carefully. So what to do? I'll bring 44 and this is 12t goes on other side. 12 divide. And when I divide 44 by 12, and I got 11 over 3. And t is less than 11 over 3. This is my required answer. And he said, set of value, there are million, trillion time, sorry, we can say starting from 0 because time is never negative. You write this way or you write this way. Both are correct, okay? Because time never negative. So you can write any one answer. Let's go for next part. Find two possible values of t for the p returns to, oh, okay, oh. Make sure, students, when you say particle at rest, so we plug in V0, but when you say returns to O, back to O. For example, this is observer. An observer, if particle goes away, come back, and this way. Whenever he come back to observer, displacement is confirmed 0. So basic criteria for this is whenever we want to take it displacement p returns to O, so we have to plug in displacement equal to 0. But first question, do we have displacement? Not at all. I am on the level of velocity. I have to come down one level down. So I have to go for integration. So let's start. So first of all, I'm going for integration. And velocity expression, I'm writing. Let me write in order, negative 60 square plus 44t, negative 36, okay. Now, student, I'm integrating. So when I integrate this v, I got a s, integral sign. I think I must t, okay, miss t. Yeah. So 44t minus 36, I think sign is issue. Yeah, sign is okay. 40 positive. And dt must be there. Increase the power by 1 divided by same. Increase the power by 1 divided by same. And 36 become 36t and plus c. And for your knowledge, it is starting from O, is leaving O. It means when time is 0, it is displacement is 0 because it's not covered any distance. So I'm putting here when time is 0, S is 0. So this is becoming, before I complete it, I simplify. So this is a 22. Now I'm plugging S0 and common sense. If all 0, so C left. So C becomes 0. I'll plug in this back in this equation. So displacement, finally, I got negative 2t cube plus 22t squared, negative 36t. But I have to plug in back to O, or back to observer. So displacement, I have to put equal to 0. So when I plug in 0 here, students, so so I will take a negative t common, and if I take a negative t common, so I get it what here? I got t square negative 11t and plus 18. So t is cannot be 0, that's gone. And here I'm going to apply quadratic formula. 18, 9 2s are 18, or just show once. I think 9 2s are 18, so I can factorize better. So 9 2s are 18. Avoid quadrant formula and factorize better. 9 2s are 18. T is common, t minus 9, and negative 2 common, t minus 9. I got t minus 9 and t minus 2. And I got 2 times. Time is 2 seconds. and time is 9 seconds. So it means it will back to, you can look at diagram here, rough idea I give you. So when it goes, this is observer. So first its particle is going away. So it turns back, it passes to observer and go back again. So this situation possible we have. Okay, I hope so. Got it. So there are two possibility here. Time is 2 seconds, and here time is 9 seconds. So two time the particle will come back to observer, and I believe the concept is very clear. And question is over. Question number 3 we have, and he said four forces given P 10, 16, 2 Newton, and he said equilibrium. So it means we have to care about equilibrium. And what is the method? It has a no component breaking because parallel to y-axis, it has a component breaking. So components we have two, one parallel to x-axis. You can see an angle 25 here, and angle with the x always with the angle. What is that? Is a cos component. So 10 cos 25, and this component parallel to y-axis because no angle here. So this is called sine component. So 10 sine 25. So let's talk about this one, this 2 and 40. So one force acting parallel to x-axis and one acting parallel to y-axis. And this is 40 here given. So this is 2 cos 40. And this is 2 sine 40. Now let's talk about last 16. And he mentioned, let me see what he's saying here further. Is it mentioned the resultant force? No. Okay. So four forces. So 16 theta, 16 angle theta. But make sure in this one, he done a slightly change. So make sure theta mentioned here. Mostly he mentioned theta with x-axis, but this part, he mentioned theta with y-axis. So this becomes 16 cos, where theta given, that is always cos, keep in mind. Like for example, is 40, so cos 40, here not given, so sine 40. So same here, this becomes 16 sine theta. Okay. So forces resolution done. So let's talk about x-axis. So rightward forces equals to leftward forces. So I can say here, students, so 16 sine theta plus 2 cos 40 is equals to 10 cos 25. I repeat my words. These two forces is sum equals to this one, okay? Because equilibrium means rightward forces equal to left forces. Done. I can bring on the other end and divide by 16. I get a sine theta subject, which I can make it easily if it goes there and subtract. So I am typing 10 times 2 cos 25 minus 16 times minus 2, sorry, minus 2 times 2 cos 40. And I'm getting here 7.53 divided by 16. And I got it 0.47069. I took a long numbers. Reason for accuracy. This is equation number 1 done. So let's talk about upward force is equals to, wait a minute, I think if we can find it from here easily, theta also. So no need to say 1, or I can say 1 even, no issue. So take a sine inverse. So when I take a sine inverse of this, students, I got it 28.07 and 888. So rounding answer turned to be 28.1 degree because the angle we always take 1 dp. So this is a rule of the topic. Okay, so we got it. The angle is done, and now students, we are going for the P force. So how to get a P force? Very clear. This is equals to this upward is only one force, and downward force is 1, 2, and 3 forces acting downwards. So I can say here, so P is equals to what? Sum of the all 3 forces. And I'm writing here 16 cos theta plus 2 sine 40 plus 10 sine 25. But make sure I will not plug in this theta here, wrong. I will plug in the full value for more accurate answer. So 16 cos in the bracket 28.07888 and plus 25 sine 40 and plus 10 sine 25. Simply plug in the calculator and we will get our answer. And if I plug in calculator, I get 16.9 newtons, 3 SF after typing in calculator. So I hope so. The point is very clear and the question is completely over. Question number 4 we have now, students, of a car of mass 1400. Okay. So I'm writing here mass is equals to 1400. Okay, kg. So what speed of car is v, the magnitude of resistance to motion is this one. So friction force is given by him kv square. Car moves a constant speed of 24 up the hill. It means speed is a constant and speed is a constant is 24 and naturally acceleration is 100% zero because we say constant speed. And inclined angle, it means is a moving an angle alpha and sine theta values given by him. So find if the speed of magnitude is at this speed of magnitude, friction force is 480. So I'm starting now. F is equals to kV square. So at the place of friction, I put 480, K unknown, and speed is 24. So when I use a 24 to power 2, and when I divide, so very simple, I divide 480 divided by 24 square, and I got a K value 5 upon 6. So let's go for next part. Find the power of engine working. So naturally, as I said before, inclined plane, you have to be careful. Diagram is very, very important. Don't be lazy in diagram making. So a car, just make a rough, this object is applied force. And this is a weight component. Okay, I make it two things here. And this is frictional force, and this is a weight component. And what is a weight component? Mg sine theta. Or mg sine theta or alpha, no problem. Alpha is here. And all of you know the power formula is F into V. If I bring it V under it, so this force becomes power by V. So this all points are clear. And now I'm going to apply the all data. Okay, let's start. Because basic formula is what? Net force is equals to MA. But as we know, acceleration is 0 because constant speed. So I'm writing now because motion is upward, students. So I will apply from here. I will apply from here. Make sure. Some student by mistake apply from here. No, you have to apply where the particle is moving. So I'm writing from here P over V minus friction, which is a kV square. Okay, okay, let me write first formula. Mg sine theta is alpha is equals to 0. Now power is unknown, speed is 24, friction is a kV square, K is 5. So I'm writing here 5 over 6 into 24 to power 2. Or I can use it, that friction force 480 also, no problem at all. Why I do this one? So 480 I can use even. Okay, 480. Same thing. Okay, we're going to same thing. Mass is 1400, gravity is 10, and sine theta is given by him is 0.12. 0.12. You see, students, so this whole thing I'll bring on the right-hand side. So P by 24 is equals to 480 plus 1400 and one more 0 into 0.12. And this value is 2160 multiplied by 24. And I got a power 5184 watt. I believe you got a point very clear. So alhamdulillah, part number 2 is over. Make sure this part A is a title. Okay, under this title we have 2 parts, 1 and 2. But now he is starting part B. It means that part 1 is part A title is no more applicable on this B now. So the top well, the paragraph is applicable on B as well. So now car moves constant speed. It means I am writing here acceleration equals to zero. And straight level road, it means horizontal motion. Given that the engine power is this time 54 kilojoules, so 3 kilowatts, sorry, three more zeros, I will bring it here. Find its speed. So basically, what is the situation? Applied force is a power, and backward, okay, I think I should write applied force. And backward is a frictional force. And what is the net force formula? So net force is equals to MA. Capital F minus small f is equals to MA. But constant speed, I will write here zero. Okay, this F formula, this is a power is equal to F into V. So V goes down. So power by speed equals to friction. And power is a 5 4 0 0. Speed is unknown. Friction is, we have it, students, kV square. K is kV square. First, I'm writing kV square. And then I am writing K value is what, student? 5 over 6. So 5 over 6. V cube. And after this, students, I'm going to apply, and just a minute, let me check in calculator. So if I apply, so it means V cube turns to be 54,000 times to 6 over 5. So 54,000 times to 6 divided by 5 and take cube root of this. Yes, so if I take a cube root of the whole thing like this, so 5 4 0 0 into 6 over 5. So speed is coming with me is 40.16. And if rounding, I got a 2 meter per second. This is, I think, over. And last one, previous question is one mistake while attempting in quick time. So this is a not 16.9, 19.6. So I got a same in calculator, but I type in quickly, okay? So I hope so. The concept is very clear. Question is over. Question number 5, we have a particle of mass 0.8 kilogram. Okay, so mass is equals to 8 kilogram, 0.8 kilogram. Read and write. And a rough plane which is inclined 28 degree mentioned already, so no need to do it. Even he mentioned also here, no problem even. Okay, equilibrium means acceleration is confirmed zero. And D tension, so this force x at 35 degree is very clear given in diagram. So coefficient of friction is given 0.2, so mu is given by him is 0.2. Okay, and find least and largest to keep the particle in a equilibrium. So first of all, student, what to do? We will have a one component, first of all, mass. This mass into 10, it very well. This becomes 8 newtons. Okay. And the weight component acting downwards, whatever the situation is, mg sine theta. What is the mg sine theta? Okay, mg. So mg sine theta is mg sine theta. What's the mass? Is a 0.8 into 10 and sine theta 28. Okay, so I think if I leave as it is, no problem at all, 0.8, or you type in calculator, better. Okay, so I'm getting here 3 point, I'm getting here, just a minute, please. Okay, so this I'm getting here, or I think it's better to write in a exact form. Okay, otherwise, so is 8 sine theta. So I'm writing here 8 sine 28. Okay, so this is done. Okay, now students, it is obviously T has two components. One is acting this way. I will talk about friction at the end. This is 35. So T cos 35. Okay, this is a one component acting here is T cos 35. Okay, I did not talk about friction up till now. And all of you familiar, this is R component, one acting upwards. So this capital R and this is 8 cos 28. Okay, I think student up till here is very clear. Now, according to situation, particle goes up or down. These two, three component remain same. So I can say these two sum equal to that. So first of all, I'm going to write R plus T cos 35 is equals to 8 cos 28. So I bring this part on the other end, or I can say here, yeah, I think so. Okay. Because mu r F is equal to mu r friction force, I can find even. Okay. So I bring this on the other end. So I got it. R is equals to 8 cos 28 minus T cos 35. Basically, R is equals to, uh, basically, what is the, we have formula? F is equals to mu R. So I'm finding F is equals to mu R. And what is the mu value is given 0.2. Actually, I'm finding a friction completely, which less difficulty later on. 8 cos 28 minus T cos 35. So students, I'm going to type in calculator now. So 0.2 into 8 times 2 cos 28. And my first value, I'm getting 1.4127. And when I multiply with that, no need of time do it. Okay, the 0.2 into cos 35. So students, I'm getting here 0.1638 T. So this is a friction force I got finally. Okay, now I will do what, students? So I will decide about the friction force now. So let's start. But first of all, what I'm going to do, this is a force, is very clear, T. Or if I don't make it, no problem. Or inclined plane is very clear. Okay, and this is 28. Okay, this is not a compulsory. Why I'm doing so? I want to bring this diagram and copy paste 2 times. Copy and paste. First, I want to do for, okay, this is done. Okay, so this is done. Now let's talk about least force. So least force, if a least means about to fall, no, least force means like about to fall down. This is called about to fall down. Like as a very less force is not able to pull it up, but is about to fall down. This is called least force. So where is the friction? Friction will be naturally upwards. So this is the most critical point which I drew now. Okay, students, now I can say what net force is equals to MA. Because, okay, now this force plus this force equal to that. So, or you can say this plus this minus this equal to 0. So I'm writing T cos 35 plus friction force minus 8 sine 28 is equals to 0. And friction force will come from here. And then I will get my answer. So T cos 35, friction value come from here completely, plus 1.4127 and negative 0.1638 T and negative 8 sine 28 is equals to 0. Now I'm going to finalize this T and this T. I'll keep it here and I will take common out cos 35. Wait a minute. Cos 35 and negative 0.1638. What happened? I have taken T common out and this cos 35 and this will stay in the bracket. And this one I will bring on the other end and I will type in. So 8 times 2 sine 28 and minus 1.4127. And I got it here 2.3431. And this whole thing will go down and I will get here first tension. So 2.3431 divided by cos 35 minus 0.1638. This is my first answer going to come. And just wait, students, let me write it. Final answer, cos 35 minus 0.1638. And this is my first answer going to come. And that answer is coming with me is 3.57. 3 point 3.57 or 3.33, I think. Just wait. I'll check again in typing calculator. Question number 5, we have mass 0.8. Okay, students, and mention here 28 degree. We can see an equilibrium. So equilibrium means acceleration is confirmed equal to 0. And we have further given coefficient of friction given 0.2. So mu is equals to 0.2. So students, first of all, make a component breaking. This is what, students? This is obviously into 10. I got 8 newtons. And what about this, student? This is 8 8 sine 28. Okay. And what about this R? This R is there. So this is 100% clear. Upwards R. And this is 8 cos 28. Now let's talk about this component breaking. Make sure. So one force acting parallel to surface. Okay. And one perpendicular to surface. So this is a 35. So this angle is 35. So this is a T cos 35. Very clear. And is a T sine 35. Okay. Now, student, what to do afterwards? I think this is all done. I did not decide yet for the friction force, so we'll do later on. So basically, what is the R component? These two forces acting upward and this downward perpendicularly. So angle 90 degree, angle 90, angle 90. That is why all I have taken 90-degree component. So so I'm writing R plus T sine 35 is equals to 8 cos 28. So it goes on the other end, and I'm writing here R is equals to 8 cos 28 minus T sine 35. And what is the formula of mu is given? F is equals to mu R. F is equal to mu R. So 1 minute, please. Let me write it close because otherwise I can't write through. Okay, mu is what? 0.2, students. So 0.2, and R value is 8 cos 28 minus T sine 35. Now I will multiply 0.2 inside, so I can get, okay, 0.2 multiply with the 8. It gives me 1.6 cos 28. And 0.2, if you check it, it's become 1. Or I just write 0.2 times to T sine 35. There's a friction force. I got it. So now, students, I will go for next plan. So because this diagram, I will copy twice. Why twice? One about to move upwards and one about to move downwards. So let's copy it here, and I'm pasting here. So this force, this I'm pasting here. Now, first of all, wait a minute, students. Okay, so I have to make this part again. That is why it is not appearing there. T, and this is angle given here, 28. Okay, so now I will take this copy just for sake of your understanding. I will paste here. So I will make it. So according to situation, if I say the least force, if I'm looking for students, so how to find least force? It means it is about to move down. It's called about to move down. Is elite acceleration is confirmed 0. So friction 100% upwards. So now, students, I can find it easily. So this and plus this and minus this equals to 0. Or I can say these two forces acting upwards, this downward, but due to equilibrium, I can put them equals to each other. So T cos 35 plus friction is equals to 8 sine 28. Now I bring this friction force down in the place, and I'm writing here T cos 35. Okay, and friction force 1.6 cos 28 minus 0.2 T sine 35. This value I kept for the friction and equals to what? 8 sine 28. Now, these 2T we have it, students. I will take T common out and this will go here. So, and equals to what? 0.2 sine 35 I got from here. So, and equals to 8 sine 28 and negative 1.6 cos 28. Actually, I brought it here. Now, student, I'm going to divide it down and let me check in all in calculator one time. So it becomes 1 minute 8 time to sine 28 minus 1.6 time to cos 28. And in the denominator, cos 35 minus 0.2 time to sine 35. And answers turn to be 3.326. After rounding, it's turned to be 3.33 newtons. This is least force. I got it. Least. Now, students, the same diagram I will copy paste here for the largest. Have a look here, student. This diagram I copy again, but this time I talk about the largest or greatest force I talk about. Is like this force is increased such a way that a particle is about to move up. So friction will be 100% downwards. I believe the point is very clear. So now again is equilibrium, acceleration is equal to zero. So this force is equal to sum of these forces. So I'm writing here T cos 35 equals to F plus 8 sine 28. So I'm going to plug in friction, but it will come on the right side. Now, and a friction value, I'm copy paste so I can make it easy. So this whole value, I'm going to copy and paste here. So have a look, students. And plus 8 sine 28. So student, there are two T values. I'll bring on one side. This will go here. So I will write it here now. T cos 35 and plus 0.2 T sine 35. And other two values, I'm just typing in calculator or I'm keeping as it is because I'm keeping accuracy level high. Okay, now T common out and this value and this will go down. I'm doing in one step so you can understand easily. And I believe this is not hard because the previous part we have done this kind of job. So here I got a cos 35, here I got 0.2 sine 35. And I'm going to type it again. And 1.6 into cos 28 plus 8 times to sine 28 and denominator cos 35 plus zero point 0.2 times to sine 35. And my answer turned to be 5.5344. And if I round it, 5.53 newtons is my answer for the largest. I hope so. Students got a point very clear. And let's go for next question. Question number 6, we have three particles A, B, C. Okay, A mass is a 5 kilogram. Keep in mind, B is 1 and C is 2. Okay, and they are rest in the beginning, and they lie X, Y, Z on a track. A lies on X, B lies on Y, C lies at Z. Okay, so okay, just make a rough diagram. A particle, B particle, C particle. It's X, Y, and Z. You say B is speed of 6. So B is, A is projected towards B with speed of 6. So it means this speed is 6. And C is projected towards B speed of V. So this speed is V. And this in the particle B has a no speed. Okay, and A collides and coalesces with B to form a D particle. It may, after hitting collision, okay, students, they will become a one particle. Name is D. And after D then collides with a C and becomes another form a particle E. So it means when they're together, C will hit and they will make a new particle. So let's try to do it and show that the second collision after speed E is this. So off speed E is this one. So let's try to do it. First of all, I will talk about A and B before collision and after collision. So this is A particle and this is B particle. Okay. And they will, after collision, they will become a one object. And he called this as a D. Okay, this is A, this is B, mass 5 kilogram, 1 kilogram, this speed is 0, and this speed is 6. So formula is M1 U1 plus M2 U2 is equals to M1 plus M2 and into V. So 5 into 6 because multiply them. So 5 into 6 plus 0 is equals to this 5 kilogram 1. So 5 plus 1, 6 into V. So this 6 and 6 will cancel and we get a velocity of 5 meter per second. This velocity of D particle. And this combined particle will go right side. Okay, this is done, students. Now we can go for plan number 2. According to plan, now a C particle going to hit this combined particle. So this is just before collision, this after collision. So this I will take. This is a before collision. Okay, and C is coming towards. This is a C, and C is coming towards speed of V. Okay, and after this is a before. This is before. This is after. Same story here. This is before, and this is after. Okay, so after they will coalesce, and they will. Sorry, 1 minute. They will make. Okay, they will make a one object. An object name is E, because he mentioned E. So this will behave as an E, and this will go this way. Okay, so students, now let's see. This is, let's say, speed after is, let's say, V1, or let VF, V final. Okay, what is the formula? Again, same formula. You know it very well. So I'm writing here the product of what is the speed of this. We have already 5. So 5 plus 1, 6, 6 5s are 30. So I'm writing here 6 into 5, and this mass is 2 kilogram. So I'm writing here plus 2 into negative V. Why negative? Because as an explanation, when one particle go away from observer velocity positive, coming back velocity negative. And because coming back, so that is why negative. Is equals to, this is a 5 plus 1, 6, and 2, 8. So 8 times 2 VF. So this is becomes 30. And this negative 2V is equal to 8 VF. And we have to prove this velocity. So first of all, I think we divide by 2. I get a 15 minus V is equals to 4VF. This 4 will divide, and we got our answer, final velocity, 15 minus V over 4 meter per second. So proved. So this is done. I hope so. The point is very clear. So next part, the total loss of the kinetic energy system due to two collisions is 63. So make sure this is a first collision. Okay, this is a second collision. So idea is very clear. We have to keep our eye on speeds and masses. So let's talk about kinetic energy before collision number 1. Because we talk about this. So what this speed is 0, what speed is here? 6. So have mv square, have m0 square, and we got a 36 divided by 2, 18, 18, 18 into 5, we got a 90, and 90 joules. Or just before hitting, when just after collision, speed is 5 and mass is 5 plus 1, 6. So kinetic energy after collision number 1. Masses are 5 plus 1, 6. Speed is 5 square. So if you look at carefully, this is a 6, 3, and 75 joules. Then what is the loss if I get a subtraction here? So loss in collision number 1 is 15 joules, very clear. This part is very clear, students. So this is done. Now let's talk about second part. Now we have discussed now this, what is going on here. So this is before collision, so I will find both. So this is a 6 and 5, we know we have it already, this one. So I will say here kinetic energy before collision number 2. And basically this part is coming once again, copy, paste, and plus. Because this is before is a combined particle, is n plus this one. So this is what is a v, speed is v, and mass is a 2. Half mv squared, 2 to cancel. This we have already 75. So this turns to be 75 plus v squared. Kinetic energy after collision number 2. After collision number 2 is this situation. This become one particle. So 5 plus 1, 6 to 7, 8. 8 and speed is finally is this. So I'm writing here half into mass 8 and speed is 15 minus v over 4 whole square. And this square of 4 is 16, 6 and 32, 8 4s are 32. So it becomes finally 15 minus v whole square over 4 2s are 16, 16, 4. This 4 comes. So as I subtracted here, I got this. So same, this minus that. Make sure this is bigger, this is smaller, I got loss. This is bigger, this is smaller, I got loss. And I'm writing here loss in, okay, I have space on next page, no problem. This loss in collision number 2. And which I'm getting here finally. So 75 plus v square negative 15 minus v whole square over 4. So I got it. So as he mentioned that total loss in both collisions is 63. I will say this plus this is equals to, so 15 plus 75 plus v square negative 15 minus v whole square over 4 equals to 63. Okay, students, what to do afterward, after this? So this gives you 90, and when this come this side out of 90, I mean to say 15 plus 75 minus 63 plus v square. This completely I'll take on the other end. So and same time, okay, so let me write first as it is, then I will expand. These three values, if you check it, 90 minus 60, you've got a 27. So 27 plus v square, and I will expand it. So 15 whole square, negative 2 into 15 into v plus v square over 4. 4 multiplied there, and it's very clear. So I'm getting 4v square plus 1088 is equals to 225 minus 30v and plus v square. V square come and subtract from here, and we got a 3v square. 30 will come here, become positive 30 with 30v. And from 2 to 5, so subtract 108, we get a negative 117 is equal to 0. So we divide by 3, or divide by 3 is okay. I got v square, I got a 10, and when I divide by 3, I got a 39. So you can go for factorization or quadratic formula. 13 3 is a 39. If I subtract them, I get a 10. So v square plus 13v negative 3v, v common, v plus 13, negative 3 common, v plus 13. I got v plus 13 and v minus 3 is equal to 0. I got two answers. One is 3 and one is negative 13, which is not possible. So my answer is, which is, I think he said to prove. Yeah, he said to prove. So we have done it. So proved. Okay, student, let's go for C. It is given that distance between XY is 36 meters. And you know, in the beginning, I showed this planning, same idea here. So this distance and this distance given by him. Okay, so let me elaborate. So distance between XY. So I think so best technique. Okay, this is X. This is Y. And this is Z. Why I take more? Because distance is more as compared to that one. 36 and 98. Okay, 36. So I think this okay. Reason is very clear. You can see because this is a 36 and almost triple is 98. Almost. Just a rough idea. This is a particle. This is a B particle, C, X, Y, and Z. Situation number 1, and what distance here given? 36 meters. Okay, I think I make it here. 36 meters. And this distance is 98 meters. Okay, and speed of A, we know in the beginning 6. And speed of, okay, the C, we got later on, V is equals to 3. And, okay, now let's see what happens, students. He's saying what a question, time between two collisions we have to find. So first collision is going to happen here. And look at here, the beginning, we know that there's a smooth, no friction here. Let me look smooth. Smooth means friction is equal to 0. So speed will not change. Speed remains same. What is speed here? 6, 6, 6, 6 throughout remains same. So this 3, 3, 3, 3 throughout remains same. In this condition, we can use this formula, which a distance is equal to speed into time. So this formula is effective in this kind of situations. So first of all, I'm going to use, 1 minute, this I drag. Okay. So situation number 1, I will apply what is the formula. Distance is 36, speed is 6. I can find time. So time between AB is what is the formula? Okay, I think I should first write the full formula so you can understand. Distance equal to speed into time. Distance is 36, speed is 6, and this goes down. I got a 6. So time from A to B before collision is 6 centimeter. This second, sorry. Why this is important? Because we know that they start same time. Okay, make sure they start same time. Okay, but problem is here when A was traveling towards B, C is traveling towards this point. Okay, so it means this is a for particle A, we got it for particle A. But what's the particle C, students? Where is particle C locates? Because same time it will take to move. Okay, so for the C, distance is equal to speed into time, and time we know 6 seconds. So if I apply distance to speed is 3, so 3 6 are 18. It means it will travel 18 meters. When it will travel to close to just hitting B, so this will travel 18 meters. So it means it is traveling and traveling 18 meters. So this C object will come here. And when it travel 18 meters, the remaining out of 98 subtract 18. So distance left between them is very clear, 80 meters. So this distance which left behind between them is 80 meters. Okay, now I'm going to show you coilers. So for example, this is a idea, copy, paste. So they are going to be together and they come here. Let's say slightly, okay, let's say no problem, we can assume here, or just here, first collision, no problem. And situation is, where is C? C is here. Okay, and this is a number, just a timeline or distance line, you can say. Okay, and distance between them is now 80 meters. This is a 80 meters distance between this to this. Now, definitely they will collide. So when they reach in the middle, all three objects, so they will collide here. Let's say they collide somewhere here. Second collision. So when second collision happens, so can I say distance traveled by the AB and distance traveled by the C. So if you add them, give you 80 meters exactly. So let's try to do the third situation, which I'm doing in the middle. So I can say distance of AB plus distance of C equals to 80 meters. What is distance formula? Speed into time. What is speed of this collective particle now? And that is, we know it already. This is a collective particle speed is, after this is 5. So this is speed is 5. So 5 times 2 t. I given this t, I call as a distance. Okay, I can call as a AB, no problem. What is this? Speed of the C is 3. You know it very well. So 3 times 2 speed time of C, but their times are same, you know. Okay, I just make it time here, T. Or I label T1 better. 5 plus 3, 8T. So I got a 8T1 is equal to 80, and time 1 is second, 10 seconds. So it means what he was asking, the time taken between two collisions. So first collision, it happened here. Second collision, it happened here. How much time between that? You know, use for your knowledge, this time and this time are exactly same. And this time is 10 seconds, and that is our required answer. So it was asking for the time for the collision. So time is between two collisions is equals to 10 seconds. So I believe this part is very, very clear. Okay, Now come the point. Student, this diagram making is very easy. It's just as a teacher, please do this kind of situation planning in exam or any question like this. Time to between the instant when A is projected from X, it means when it's thrown from here, and instant when E reaches the Z. Which E particle you talk about? Which E part after collision? This all three particle, because A, B, C will collide and become coalesce and start from here and reach on Z. So it means this distance it will travel once again. But how to know distance? How much distance? There's a main part. So time between the instant when A is projected. So first time is A projected is a T 6 seconds here. Done. Afterwards, we need to find, and this time is 10 done. So we two times we have student. So total time is very clear. First time is 6 second, second is 10. Now one part left only. So this is a 6 second A to B and B to Collis point is a just I got it now 10 seconds. So this is done. Now after this coalesce that combined three particles like this three particle speed is 3. Now it will continue to reach Z. So let's see how we can get that one. This is the most important part. So let's try to do it. So first of all, we need to know how much distance from here till here. That is the main part. So distance for that reason 10. If I want speed as the combined particle is a 5. If 10 fives are 50. So distance of I'm writing here distance by AB, or we can say E part because ABC D part, D particle by D is equals to before collision, just before collision, and speed is 5 into 10, so 50 meters. 5 into 10, so it is 50 meters. So it is 50 meters. Okay. Now, students, so 50 meters. So total distance is 98, and this is a 50 meters. So we have to, from 98, subtract 50. From 98, subtract 50. So distance, how much to reach? Okay. So for distance, for E, because this after this, all three particle will become E. So for E to reach Z. So from a 98 subtract 50. So we need 48-meter distance more to reach there. How much time we need to for this? For the formula, you know this again same. So this speed will go under it, and speed of the this combined particle, all three particle is 3. So I'm going to plug in here 3. Distance we have it. So this is 48 by 3. I got a 16 seconds. So 16 come from here. And we got a 32 seconds total required to reach. I believe you got a point very clear. This is a second collision here. And because this is heavy, they are more heavy, this heavy weight. And this particle will go and reach Z. How much this distance? So this is 50 meters because 10 fives are 50. And from 98, if I subtract 58, I got a 48, and I think idea is very clear. And this question is completely over. Question number 7, students. What is the question we have here? Two particles P and Q of the mass. Okay, two particles of P and mass of 2.5. 2.5 P is 2.5 mentioned here, and Q is 0.5. Okay, and angle 30-degree given. All right. So read very carefully, and there's 2 meters gap between the levels, and P release from rest. It means starting velocity is confirmed 0 for the both particles. Okay, all right, and string taut slides down. So P sliding down, so it means it will move this way. Okay, and the P is rough, and mu is given by him is 0.2. Okay, and we need to find acceleration by the P particle. How we can do it, students? So let's start. First of all, I'm going to make it Um, this is a two. We have a, this part. This mass is a 2.5, and this weight is 2.5 into, because formula is mg sine theta. So m is 2.5, g is 10, so 25 sine 30. And tension towards pulley, that is for sure. That's for sure. And friction backwards, what's the reason? Because motion downward, friction opposite. How to find the friction force is nothing hard to do it, because because basically this is R component, and this is mg. I mean 2.5 2.5 into 10 cos 25 cos 30, because mg cos theta. So student, what is the formula? F is equals to mu r. Friction force mu is 0.2, r is 25 cos 30. And if I type in calculator 0.2 into 25 into cos 30, I will break the question, so it becomes easy. So there's a friction force acting. Okay, this is a tension, and the mass is 5 into 10. This is becomes 5 newtons. So student, now I'm going to make two equations, one for the Q particle, because this is not about, this moving downwards. So common sense, this will go upwards. So let's start formula for Q. Q formula is what? Net force equal to MA, because moving upwards, the tension is bigger, 5 is smaller. I will say tension minus 5 equals to MA. Mass 0.5, A, I don't know. Let's talk about this, because motion is downward. Some students start from here wrong. We have to start from where is motion. That is a bigger force. This force bigger. These two forces are smaller. So 25 sine 30 is basically, if you type in calculator, it comes you half of 25, 12.5. So I'm writing here 12.5 is for P particle, 12.5 minus tension and friction. I just got it 5 root 3 by 2 is equals to MA, and that is 2.5 times 2A. And this is very clear. So I'm writing it like this. Okay. All right. Okay, students. So what is going to happen now? Naturally, this positive tension, negative tension, they cancel out. And now I will type this whole in calculator. So 12 minus 5 root 3 and minus 5. I'm getting here 2.66987. And here I got a 3. If I divide it by 3, so 1 minute, let me check again. I think maybe typing mistake in calculator. Let me check. 12 minus 5 times 2 root 3 divided by 2 and minus 5. Yeah. Divided by 3. So this is 12.5, students. So 12.5. 12.5. Okay, now I type it. So 12.5 minus 5 root 3 divided by 2 and minus 5. So I get it now here, students. Here. So 3.16987 and divide by 3, and we get acceleration value is coming 1.0566, and finally I can say 1.06 meter per second square, and we got the acceleration. So let's go for this part is very clear, I hope so. And now I have to make it this same diagram on next page for the next part. So for that reason, I need to specially, okay. Okay, no problem. I can. Next part is for use energy method to find the speed of the particles at an instant when they have the same vertical height. Vertical height. So it means current situation, their height between them is 2 meters. So I'm going to make this diagram and 2 meters. So one particle is here and one particle is here. And the height between them is 2 meters. Okay. So this is when this is on inclined plane, you know it very well. Okay. Whereas this particle, okay, if this particle, what is the plan of action we have to do it? So let's say it moves because this 2 meters, let's say it moves x because I don't know what is that distance. Let's say is x. If it's move x, so this will move x. Common sense because they are connected. How much it will move? It will move same distance. So this is x. Okay, if you look at carefully, student, this is a triangle. I got it here. Okay, so actually, basically, we have here 30-degree. So if I make this triangle like that, you can see here this triangle. I'm going to make this triangle separate here. And this is x travel. This 90 degrees is 30-degree. And this is naturally, this is x. Out of 2x gone, this becomes 2 minus x. So this 2 minus x. I repeat, because this distance, you can see this is a height is a 2 minus x, 2 minus x. So very clear. And this is this triangle. You see there's a 30-degree. I drew this triangle here. Whereas this x is obvious. This is a 2 minus x. I think you understood why I made this triangle. Now, opposite by hypotenuse. I mean to say it like this. Is equal to sine 30. And x sine 30 is what? Half. You can check in calculators. 2 multiplies there. 2 2s are 4. 2x is equal to x. This goes there. I got a 4 equal to 3x. So x becomes 4 over 3. So this is 4 over 3. And you can say this. Look at same vertical height. They will come. But thing is that how much this left behind? How much this? It is this traveling distance is naturally x 4 by 3. This is also 4 by 3. But how much is this? How much is this? I want to find it. So this plug in it here, 2 minus that. So I call as a V. So 2 minus over 3, 3 to the 6, 6 minus 4, 2. So 2 by 3. So Y becomes 2 by 3 meters. Meters. Now, students, what's the plan of action? He's saying that we use energy method to find the speed of the particles in instant. So speed, our task is to find speed. Okay, basically, students, if you look at carefully, okay, so this speed, this is let me check it, what's particle names? P and Q, 2.5. This is a P, so 2.5. There's a Q, so 0.5. Make sure. Okay, so let's try to solve it. What is the method to do it? Basically, what is the formula we use? Work done by applied force, work done by frictional force, kinetic energy plus potential energy at an end point minus kinetic energy plus potential energy at a starting point. Basically, we have two particles. When a two particle come, we call a system. Okay, so when I open the bracket, k at the end, potential energy at the end, kinetic energy at the end, and minus potential energy at the end. But you know, sorry, this is starting. This is not ending. Sorry for that, students. Okay, okay, this is starting, and this is a start. Okay, basically, you know, when it's starting, it's because start from rest. You know it very well. Starting from rest, he mentioned here, start from rest, release from rest. So ke kinetic energy at start is confirmed 0. And basically, if we check it here, in this situation, when this particle is falling down, we can say because starting is zero. We can say gain in kinetic energy. Why gain? Why gain? Because starting is zero and at the end is high speed, plus loss in potential energy. Why loss in potential energy? Because it is losing and it is gaining, but I think loss is a more, we will get automatically how loss. So it will come automatically. Let's see. So this is zero logic because it is sliding due to its own weight. So no applied force. When no applied force, work done by applied force is F into D. So this is zero, gone. And now what is this one? So small f into D. And friction force we have already. We're on the top. If you look at carefully, 5 root 3 by 2, 5 root 3 over 2, 5 root 3 over 2 friction force. And distance is how much it travels. It travels is x, and that is 4 over 3. So 5 root 3 divided by 2 into 4 over 3. Okay, into 4 over 3, and it becomes negative 10 root 3 over 3. Okay, gain is, kinetic energy, we can say, because both particles are there. It will also gain starting from, speed become higher. It start from here, rest, speed become higher. So both speeds are gaining. So I can say half 2.5 v square plus half 0.5 v square. Logic is very clear. One mass 0.5, one mass 2.5, and both will gain speed. If we check it carefully, students, okay, so this is a 2.5 and 2.5 plus 0.3. So this becomes 3 by 2 v square finally. And here I have already this one. So let's discuss loss now. This is an important part here, students. Wait a minute. Okay, so try to solve this part. When it will go up, it will gain the height. And when this will come down, it will lose the height. How much lose the height? This much lose the height. How much this gain the height? X is 4 by 3. So m mass this and gravity 10 and height is a 4 by 3. So I can say here mgh, mg and h, and plus. And what about this? It will lose, not plus, it will lose. So it, because it is coming downwards, so I write minus here. So what is that? 2.5 into 10 into what is the height is losing? Is losing, y is 2 by 3. So into 2 over 3. So now students, let's try to solve it. What is this and what is this? I'm typing separately. 5 into 4 by 3, and I got a 20 by 3. And what is that? 25 into 2 over 3, I got 50 over 3. Okay, students, so this both will bring on the other end, but first I type it. 20 divided by 3 minus 50 divided by 3, I got negative 10, 10 goes there, positive. There's a negative 10. That is why it's called loss. Okay, and I show you, no issue at all, so you can understand why is loss. Now this minus 10 will come here, become 10 add. So now students, I'm typing 10 minus 10 root 3 and divided by 3. I'm getting here 4.22649. Into 2 by 3, I got a v square. Into 2 divided by 3. And I'm getting here v to power 2 equal to 2.81766. Take a root of this, and I got a velocity 1.678, which become 1.68 meter per second. So I believe the point is very clear. And the question is completely over. Okay, I hope so. You got idea. And best of luck for the exam. And which question you're getting problems. So please, after class, after watching this video, re-practice. Practice again, one time or two time. So, assalamu alaikum wa rahmatullah.